algorithms, best fit, first fit and worst fit algorithms, places these processes. These are the list of processes which has come in this particular order. That is, 212 KB program comes first to be placed in memory, then 417 KB program, okay, and then 112 KB program comes to the memory, and then 426 KB program comes to the memory. Okay, now we have to check which algorithm makes use of efficient use of the memory. Okay, first of all, draw the memory space. Okay, these are some programs which are already there. Programs which are already there, you can put just a slash indicating that it is not free. The spaces are not free. Okay, something is already there. Fine. And then these are the free spaces which is available. These are the free spaces. Okay, so free spaces 100 KB followed by 500. Okay, 500 KB, 200 KB, and then 300 and 600. Okay, in the internals or the exam you have to do the same way. So there is this spaces which is available. Okay, now you are supposed to place these programs according to these algorithms: first fit, best fit and worst fit. Okay, now first we'll check for first fit, how the programs are placed. Okay, the same memory space, and I am taken the spaces. Okay, now first the program which comes is 212 KB. 212 KB program has to be placed. Okay, according to first fit, whichever is the biggest hole which is large enough to store this program can be selected for first fit. Okay, is 100 enough to store this file? 212 KB? No, 100 KB is not enough. Okay, yes, 500 KB is enough to store this program. Okay, and so this program is and 500 KB is the first space which has come. Okay, so 212 KB will be placed in that particular position. Okay, so program of 212 KB is stored there, and now the space remaining is 500 minus 212. That program is occupied. 212 KB the program has used. Okay, so it is 8 and 8 and 2. Okay, so it is not 500, it is 288 KB which is remaining. Okay, now these are the spaces, holes which is remaining. Next program to be placed is of 417 KB. Okay, 417 KB has to be placed, which is the first space which is large enough to store this process. So 100 is not enough, 288 is not enough, 200 not enough, 300 is not enough, 600 is enough to store this program of 417 KB. Okay, so there the program is stored, okay, continuously, and it is 600 space is not free now. 600 minus 417, okay, that is 183 KB is free now. Okay, next program to be placed is 112 KB is the next program to be placed. Okay, which space? Again search from first, check which space is enough to store this program. 100 is not enough. Okay, 288 is enough to store this program of 112 KB. Okay, so 112 KB is placed here, and it is not 288 space. 288 minus 112 is 176. So 176 is the space remaining now in this particular hole, which was there earlier. Okay, only this is the space which is available now, that is 176. Okay, now next program to be placed is 426 KB. Search for the hole which is where the program can be stored. 426 KB. 100 is not enough, 176 is not enough, 200 is not enough, 300 is not enough, 183 is not enough. Okay, now there is no space to locate that particular program. 426 program cannot be placed. Okay, so this program cannot be placed. This is according to first fit. Okay, next we'll check for the best fit. Okay, so best fit algorithm. So according to best fit, the search through all the spaces, and the program which is large enough, the space which is large enough to store the program, the smallest space which is enough to store the program, there the program is placed. Okay, now take the same memory space. Now we are checking for the best fit. Okay, same memory space is taken, the initial memory space. Okay, now we are checking for the best fit. 212 KB is the first program. So search through all the whole spaces which is available and which best suits this particular program. 212 KB program has to be placed. Okay, so which is the smallest hole which is enough to store the program of 212 KB? By seeing the list, you can see that 200 is not enough, but 300 is the smallest hole which is enough to store the program of 212 KB. Okay, so the program is placed there, and now the space remaining is not 300, it is 88 KB. 300 minus 212 is 88. Okay, now check for the next program, 417 KB. Okay, 417 KB program has to be placed. Search the whole list. Okay, there is 500 where the program can be placed, and then the other space is 600. 500 is enough to store the program. You need not go for 600 KB. Okay, 417 KB can be stored within the 500 KB. Okay, so store the program there, and now the space remaining there is 83 KB. Okay, let's check for the next process, 112 KB. 112 KB cannot be placed here. In 100 it cannot be placed. In 83 it cannot be placed. In 200 space it can be placed. Okay, 88 it cannot be placed. 600 it can be placed. Okay, so which is small enough to store the program of 112 KB? It is 200. So the program 112 KB is stored there. Okay, and the remaining space is 88K. Fine. Check for the next program, 426 KB. So 426 KB, you can observe it is not placed here. It cannot be placed here. But in 600 KB, the program can be placed. Okay. Hence, place the program 426 KB there. Okay. And the remaining space is there. Okay, so the program, there is some remaining space, and now here all the files can be placed in best fit. All files can be placed. Okay, whereas in first fit you had observed that the program of 426 could not be placed. Okay, next is worst fit. Okay, we'll see, take the same space allocations holes. Okay, we'll see for worst fit. What does the worst fit algorithm say? The largest space which is available and where the program can be stored, that space has to be taken, largest available space. Okay, so 212 program has to be placed. Which is the largest space available? 600 is the largest space available. So the program was placed there. Okay, I had told earlier in the class why we are taking the largest space, because we'll get the largest hole. Okay, and another program can be placed there. There will be no fragments, small fragments will not be found. Okay, and hence we check that is worst fit is implemented in some operating systems. Okay, now 388 KB is free. Okay, next 400 KB program has to be stored. So check which is the largest hole available now. 500 is the largest hole available. So 417 KB program is stored here. Okay, and there is some space which is remaining. Next, 212 KB program has to be placed. The largest hole available is, yes, observe here, 388 is the largest hole which is available now. Okay, and so 212 program is placed there. Again, there is some small space which is available of 276 KB. Okay, now 426 KB program has to be placed. There is no space which is of 426 KB or more. Okay, and so the program cannot be placed. The file of 426 KB cannot be placed. And here also there is some spaces. There is spaces here and there, but continuous space of 426 is not there. Okay, so these are the three algorithms: best fit, first fit, and worst fit. Okay, you had observed that in both first fit and worst fit, a particular file could not be placed, but in best fit, all the programs were able to store and memory was efficiently managed. Okay, so best fit utilizes the memory well.